Hello, here is King Wang, a research scientist working on electro-absorption modulator at RISE Acreo. Those modulators are produced at Electron Cleanroom facility cooperated by Acreo and KTH. Those components are very useful for different applications. One of them is for optical information processing, another one is for optical communication links. Today we are going to have one lab demonstration to show how the free space communication link works using our modulator.
So the free space optical communication we're going to show today is based on an asymmetrical link. So on one end of the link you have all the power consuming and heavy hardware such as the laser source, the optical detection and the electronic part for the detection. On the other end of the link you have only the small modulator and a few driving electronic system around it. So it makes it really light and really small, perfectly suitable, for example, ground satellite communication or satellite nanosatellite space communication. So the modulator is the center of this communication links, and since we're creating it here at Acreo, we can shape it the way we want. So for this link I'm going to use a 150 micron round pixel, and just by applying an electric field to this component will change its optical response. So this is due to a quantum effect called the Stark effect, and this will induce modulation to our optical beam. From the electrical point of view, it's really simple. My modulator is mounted here on the small PCB. I create the signal I want to send, so here it's on-off keying. I amplify it, apply a bias, and then send this to my modulator. So from the optical point of view, my optical setup here will mimic the free space optical link that I talked about a bit earlier. So my laser source here will be collimated and sent through a beam splitter. A 10-meter optical path will then be created through a few mirrors, and then the beam is sent to this optic which will focus the beam on my modulator pixel. The modulator will then modulate our signal and reflect it back toward this beam splitter after 10 meters, and my detector will catch the beam, the reflected beam and the modulated beam. So on one end of the link you have the heavy part of the setup, which is the laser source and the detection part with a few optics, and on the other hand you still have only your modulator, the one optical component and the driving electron. The small size of the modulator allows us to have a really high-speed communication link. The data rate I can reach with this one goes up to 500 MHz or 1 GB per second. I'm going to show you now a 100 MHz signal and up to 500 MHz signal now. One of the few drawbacks of this system is that the link has to be operational at all times. So, for example, if something crosses the beam, we lose completely our signal, or if you have some atmospherical turbulences, you can lose one part of your signal, and I will show this now. For example, now I'm cutting the beam, and now I spray some water on the beam, and we can see that our signal is quite disturbed. Those behaviors should not trouble satellite-to-satellite communication, but will obviously affect ground-to-space links. This drawback can be solved by using a ground network where you set the link with a station where the weather conditions are favorable, and then you transmit the data toward the desired location.